Good afternoon all. I am Chetna Chowdhury. I am going to teach you the subject Functional Analysis. The first two chapters are being taken by Mapari sir. We are taking the next three chapters. This is your third semester of MSc Mathematics. That is second year. Let us see the syllabus of last three chapters. This is the syllabus. Let us see the titles of third unit. Boundedness Theorem and some of its consequences. Open mappings, Hahn-Banach theorem for real linear spaces. So we start our syllabus. Write down all these titles in your register. We shall study all these titles one by one. First title is Boundedness Theorem. We see all the definitions required one by one. First definition is Banach space. Most of definitions we have learned in previous standards. Also, in first two chapters of this paper. And some are newly we are taking. First definition is Banach space. A norm-linear space which is complete as a metric space is called as Banach space. Norm-linear space. A norm-linear space is a vector space with a metric defined by a norm. Linear operators. Domain of a linear operator is a vector space and range is a vector space over the same field. Then T is called as operator and it is linear if it satisfies the condition T of x plus y is equal to T of x plus T of y and T of alpha x is equal to alpha into T of x. Bounded set. Every element of bounded set, its absolute value is less than or equal to small k. K is some constant. Closed set. A set which is equals to its closure is called as closed set. A closed set contains all its limit points also. Definition of ball. Given any point x0 belongs to a vector space capital X and a real number small r strictly greater than 0, V of x0, r, that is center is x0 and radius small r, contains all the points x belongs to capital X such that distance between x and x0 is strictly less than small r, called as open ball. If distance between x and x0 is less than or equal to small r, then in that case the ball is called as closed ball and denoted by b bar. If the distance between x, x0 is equal to r, then it is called as sphere. We denote it as capital S. Here x0 is center and r is radius. Now we see norm. Norm on a vector space is a real valued function on capital X whose value at n small x belongs to capital X, denoted by norm of x such that it satisfies properties of norms. That is, norm of x is greater than or equal to 0. It is equal to 0 if and only if x is equal to 0. Norm of alpha x is equal to mod of alpha into norm of x. Norm of x plus y is less than or equal to norm of x plus norm of y. X and y are vectors in capital X and alpha is a scalar. A norm on capital X defines a metric D on capital X given by distance between x, y is equal to norm of x minus y. Next definition is complete metric space. If every Cauchy sequence is convergent in a metric space, then it is called as complete metric space. Also, bounded linear operator. Let capital X and capital Y be norm spaces and T be a linear operator. It is called as bounded if there is a real number small c such that for all x belongs to domain of T, norm of Tx is less than or equal to c into norm of x. We can rewrite it as norm of Tx upon norm of x less than or equal to c. C must be at least as big as the supremum of the expression on the left hand side, taken over the domain of T minus the element 0. Hence, smallest c is that supremum and denoted by norm of t. Norm of t is equal to supremum over x belongs to domain of t such that x is not equal to 0. Norm of t upon norm of x. We can rewrite it as norm of t is equal to supremum over x belongs to domain of t such that norm of x is equal to 1 of norm of tx. These are the necessary definitions for first title. In next lecture, we see the theorems related with first title. In this way, we can easily complete our syllabus and you can easily study all the theorems one by one and cover the syllabus. Thank you.